Hello everyone, myself Amina Sheikh from B3 batch BSc second year. So today on this channel I will introduce my seminar topic, that is conductometric titration. So let's see what is the meaning of conductometric titration on my next video. So here is the definition of conductometric titration. The titration in which endpoint is determined by measuring change in conductance of solution upon addition of reagent is called conductometric titration. The conductance of a solution depends largely on the number of ions and their mobilities. Here are some 5 examples of conductometric titration as given below. My first example is strong acid against strong base, HCl against NaOH. It means hydrogen chloride against sodium hydroxide. Consider the titration of strong acid HCl against strong base NaOH. The acid is taken in conductivity measured in alkaline in burette. The conductance of HCl is due to the presence of H positive and Cl negative ions as alkyl is added. Gradually, H positive ions are replaced by slow moving Na positive ions. Until the complete neutralization, conductance decreases on addition of NaOH. Any subsequent addition of alkali after n point will result in introduction of fast moving OH negative ions. The conductance therefore increases on further addition of alkali. So, in this diagram, the variation of conductance is plotted against volume of alkaline added. We get two straight lines meeting at point B, which represent endpoint of titration. Example number second, weak acid against strong base. CH3 COOH against NaOH, it means lactic acid against sodium hydroxide. When acid is weak, conductance is low. On addition of strong base, poorly conducting acid is converted into high ionized soil, and hence conductance increases slowly up to the equivalence point. Beyond the equivalence point, addition of alkaline causes sharp increases in conductance due to excess of hydroxide ions. Example number third, strong acid against weak base, HCl against NH4OH. It means hydrogen chloride against ammonium hydroxide. In this case, conductance initially decreases due to the replacement of fast moving H positive ions by slow moving NH4 positive ions. Beyond endpoint, further addition of weakly ionized NH4OH will not cause any appreciable change in conductance. The point of intersection of curve is the endpoint of titration. Example number 4, weak acid against weak base. CH3COOH against NH4OH, it means lactic acid against ammonia. In this titration, conductance initially increases because of formation of salt, that is CH3COONH4, it means ammonium ethanoate, which is strong electrolyte. This increases continue till end point. Beyond end point, the conductance does not change appreciably. Now the last example, that is fifth number, precipitation titration. AgNO3 against KCl, that is silver nitride against potassium chloride. So the titration of silver nitride against potassium chloride involves precipitation formation, that is AgNO3 plus KCl is equals to KNO3 plus AgCl negative. It means silver nitride plus potassium chloride is equals to potassium nitride plus silver chloride negative. Since mobility of Ag positive and K positive ions is nearly the same, the conductance remain almost constant till the equivalence point. After equivalence point, the added KCl increases the conductance rapidly. Now we will see advantages of conductometric titration. Number 1, small quantity of solution is required for titration. Number 2, as endpoint is determined graphically, no special precaution are necessary. Number 3, indicator is not required, so conductometer titration are used in titration of color and turbid solution. Number 4, conductometric titration are used for analysis of dilute solution as well as for weak acid. And number 5, Conductometric titration can be applied to mixture of acid, precipitation and other types of titration. And number 6, conductometric measurement give more accurate result. Thank you so much for watching my video.